Hey guys, welcome to Pre-Calc Lesson 2.3. Today we're going to be talking about the characteristics of polynomial functions. So let's just review some of the basic functions that we've discussed already. The linear function. What if it has a leading coefficient that is positive? Oops, I put a square and it should be to the first power. What if the leading coefficient is positive? What does that tell us? Well, it tells us that the line is rising. If the leading coefficient is negative, so if the variable has a negative out in front, the variable x, then that means that the line is falling. That is from the idea that f of x equals y equals mx plus b, right? F of x is the same as y equals mx plus b. The slope is the number that's multiplied in front of the variable x, and the slope decides whether a line is rising or falling. Quadratic functions have a highest exponent of 2. Now, if the leading coefficient is positive in a quadratic function, that means the parabola opens up. But if the leading coefficient is negative, then the parabola opens down. Cubics have a highest exponent of 3. If the leading coefficient is positive, that means that the right side of your cubic needs to open up. I just realized I switched these colors. I'm going to stay consistent and keep doing the positive coefficients as blue. So if your leading coefficient is positive, then the right side of your graph is rising. And that's true for all the previous ones that we've done that have a leading coefficient that is positive. I'm going to review that with you guys later. But notice, anytime the leading coefficient is positive, the right side of your function is always rising. Anytime the leading coefficient is positive, the right side of your function is rising. But if the leading coefficient is negative, then the right end will be falling. Okay, quartics, you might not have been exposed to too much. Quartics are functions where the highest exponent is a 4. If the leading coefficient is positive, then the right side is rising. Now, these shapes kind of look like W's. They don't have to be symmetrical, so they can be lopsided. One side can dip lower than the other, but essentially they're W's if they open up or M's if they open down. Again, the leading coefficient, if it's negative, the right side is going down. But if the leading coefficient is positive, then the right side is opening up. The lesson today is based heavily on vocabulary words, some which look familiar to you and some which will be new. I highly recommend that when you have time, you make some flashcards to help you study this. That can easily be done with some Google extensions and apps. Okay, the first word, degree, you should recognize that word. We've discussed it in our class and you've discussed it in previous math classes. Degree is the highest exponent of a function. So before you commit and say, oh, the degree is 5 or the degree is 2, make sure you look at each term because they're not always written in order. So not every equation will be written in order from biggest exponent to smallest. You have to look at every term until you find the biggest, okay? The leading coefficient, and remember, coefficient is any number multiplied with a variable, but the leading coefficient is the coefficient of the variable with the highest degree, aka highest exponent. Remember, the highest degree is the highest exponent. Now, I might have mentioned it to you guys before in class. Not sure if you caught on to it, but when you are solving a function, okay, when you're solving a function, the solutions can also be called zeros. So zeros, remember, sorry kids, I have something in my throat, are also known as solutions. You can write them as x equals, like x equals 2, x equals negative 1/3, whatever. The most amount of zeros or solutions that a function can have depends on the degree. Okay, so the most amount of zeros, solutions, x-intercepts, remember those are all related. The most amount of zeros and solutions is based on the degree of the function. So if your highest exponent or your degree is 3 and you have a cubic, you cannot have more than 3 zeros. Okay, so that's the most. 3 is the most. You can't have 4 solutions for a cubic. So the most amount of solutions or zeros is the same as what the degree is. Now, max number of turns. Turns is any time that your function switches directions from increasing to decreasing. So it's any time your function switches directions. We call them inflection points. So like it might be falling, then it starts to rise, then it falls. Anytime it switches directions from rising to falling. In chapter 1, part 1, we called them maxes and mins, those inflection points, anytime it switched directions. Now, the max number of turns has to be 1 less than the degree, okay? So the amount of switches, I'll call them switches in direction, is 1 less than the degree. So what does that mean? That means that if you have something like a parabola, right? So let's just think of it a parabola. Let me actually pause the video now so you can finish writing the definition. But when you're ready, look at the parabola that I have up here that opens down, okay? If I trace that parabola from left to right, it's rising, and then at the vertex, it switches directions. That's called an inflection point, and then it starts falling. That's if I trace it from left to right. So that's an inflection or turn of 1. The max number of turns is always 1 lower than your exponent. So since the exponent was 2, the most times that the parabola can switch directions is once. The cubic. So let's take a look at the inflection points on a cubic. It switched directions here and here. That's 2. So that's 1 less than the degree. So it was falling, rising, so that then it switched, and then falling again. So it switched twice. The quartic, right, switches directions 3 times. That's 1 less than the degree. When you are looking at a graph of a function, you might be asked to describe the end behavior. Now, there's always two ends. There are always two ends. The right end, the right side, and the left end, left side. This is so important for you guys to make sure that you take the time to study and memorize because there is very specific notation. So you have to learn how to write the answers. There's very specific ways of writing your answer, and it could get a little confusing, okay? So this is what you want to spend a bit of time reviewing, studying, and looking at. Okay. Right end behavior. Okay, when you're asked to describe what's happening on the right side of your function, is telling you to read the graph from left to right. So it always is going to start like this. As x approaches positive infinity. What does that mean? It means as I move to the right on the x-axis, so positive infinity is on the right. As I move to the right on the x-axis, what is happening to the f of x values, which are your y values? Okay, so again, you're always going to start with as x approaches infinity because that's the right. Positive infinity is on the right when you're looking at the x-axis, okay? So again, this means as I move to the right on the x-axis. That's how you're going to start it, okay? So as you move to the right on the x-axis, what happens to the y values? Quick reminder, and maybe put this off to the side. Quick reminder, important reminder, is that f of x is referring to the y values, okay? So f of x is the y values. Okay, here are the rules. If your leading coefficient is positive, then your y values are going to rise on the right end. However, if your leading coefficient is negative, then your right end y values are going to fall. So leading coefficient is positive means that your right end y values are going to rise. But if your leading coefficient is negative, then your right end y values are going to fall. It sounds confusing, but I promise that the more you practice, it'll get easier. So again, the right end behavior is always going to start with as x approaches positive infinity, because when you go to the right on the x-axis, you're going towards positive infinity. And you need to memorize that the leading coefficient of the function tells us that the right side is rising. But if the leading coefficient is negative, I just realized I forgot the I in positive. Oh my goodness. Spelling mistake. Okay, but if the leading coefficient is negative, the right side is going to fall. Positive coefficient means the right side rises. Negative leading coefficient means that the right side falls. How is right end behavior different than left end behavior? Well, now you're reading the graph from right to left because you're looking to the left on the x-axis. Okay? So you're going to say, what's happening to the function as I move to the left on the x-axis? Now, I don't decide the left end behavior until I know what the right end behavior is, because the left end behavior depends on the right end behavior, okay? So I'm going to write that down for you. So the left end depends on the right end. You have to decide what the right end behavior is going to do before you can decide the left end. How come? Because if your degree is even, then you need to just make sure your left end notation is exactly the same as your right end in terms of what the y values are doing. Think about a parabola, right? This is just an example, a parabola that opens up. The right side has an arrow pointing up, and so does the left. Any function that has an even degree has the same thing happening on the left end and the right end. In this case, the y values are rising because the arrows are both pointing up. Okay? But if you have something like an odd degree, okay, something like a cubic, if it's an odd degree, then the left is going to do the opposite of what the right end does. And look at the arrows. We have one arrow that's pointing up on the right and an arrow that's pointing down. So that's just an example to show you that if the degree is even, both the left end and the right end have to match. They have to be the same. But if the degree is odd, then the left end does the opposite of what the right end does. If one rises, then the other one falls. All right, let's practice. For these first four examples, they want to know the degree, the number of times it switches directions, or max number of turns, and the max number of zeros or solutions. Okay, so degree. Now, what is degree? Degree asks you for the highest exponent. So it's important for you to take a minute and look through all the terms till you find the one with the highest exponent. So the degree here is quadratic, it's a 2. The maximum amount of turns, or times that it switches directions from rising to falling, is always one less than the degree. So think about it. This is going to be a parabola that opens up because the leading coefficient is positive. How many times does the parabola switch directions from rising to falling? Only once. Now the max number of zeros always is the same as the degree. A parabola cannot have more than 2 solutions. Okay, the next one is a quartic. The leading coefficient is positive, which means the quartic opens up. That we reviewed on the chart that we started with at the beginning of the notes. The degree is the highest exponent. The max number of turns or times that this switches directions is 1 less than the degree. So 4 minus 1 is 3. And the max number of zeros is 4, because it's always the same as the degree. You cannot have more than 4 answers for a quartic. Okay, go ahead and pause the video. Try the next two on your own. Take a minute to circle the term with the highest exponent. Make a quick sketch if you want, and then identify the degree, max number of turns, and max number of zeros. Push play when you are ready. Please try to do these next two by yourselves. Okay, number 3 is a cubic. The leading coefficient is positive, so that means that the right side is rising. Left side has to be falling. Odd functions, remember, have ends that are doing opposite things. So if one arrow is pointing up, the other one has to point down. The degree is 3. The max turns is 1 less than the degree. And the max number of zeros, or solutions, or x-intercepts, is the same as the degree. The next one is a quadratic with a leading coefficient that's negative. If the leading coefficient of a quadratic is negative, the parabola is opening down. Since it is an even degree function, the left end and the right end have to be doing the same thing, whereas an odd degree, like a cubic, will have arrows pointing in opposite directions on the left end and the right end. The degree is 2. The max the maximum amount of times that this function can switch from increasing to decreasing is 1, and the max number of zeros is 2. Parabolas cannot have more than 2 solutions. They can't intersect the x-axis more than twice. Remember, you can pause, rewind, and stop the video at any time. This is probably the harder part of the lesson, identifying the end behavior. It's hard because you have to adjust to a new format or a new notation of how to write your answer. The sketch will always help. So I'm going to start the same way that I started the previous problems. Look for the highest exponent and make a quick sketch. This is a parabola that opens down. According to the rules, the leading coefficient, if it's negative, means that the right side is opening down. Since it is an even degree function, the left side and the right side need to be doing the same. They need to be both pointing down or both pointing up. So I'm going to go ahead and draw that sketch over here. Okay, now the leading coefficient affects the right end behavior. Okay, if the leading coefficient is negative, then the right side of your graph is going to be falling. So how do we tell that as an answer? You're going to start with saying, as I look on the x-axis and move to the right, so as x approaches positive infinity, that little arrow, remember, means approaches. So as I move to the right on the x-axis, the y values, f of x, the function, is falling. So it is approaching negative infinity. So on the x-axis to the right is where positive infinity, on the y-axis negative means down. So since the arrow is pointing down, you want to use negative infinity. Okay, how do we decide the left end behavior? Well, we have to look at the degree. The degree was 2, so the left end has to do the same thing as the right end, but the notation starts off a little differently. So you're going to start with, as I look on the x-axis and move to the left, so negative infinity, the y values should be doing the same thing that they did previously, right? Because both of the arrows are pointing towards negative infinity. So as I move to the left on the x-axis, my y values, or look at your arrow, is pointing down. Notice that when you're talking about end behavior, you need to give me 2 answers, the right end and the left end. When you're describing the right end, you're going to start with describing the x values. As I go on the x-axis to the right, so as x approaches positive infinity, then tell me about the y values, f of x. But for the left end, you start with as x approaches negative infinity. So as I go to the left on the x-axis, what happens to the y's? So again, you need to make sure your notation is on point. Talk about the x's first, then talk about the y's. Look at the leading coefficient. What is the highest exponent? That will help you make a sketch. The highest exponent is 3. Since the leading coefficient is positive, that means that my right end behavior should be rising. Okay? All right, but let's make a sketch. So this is a cubic where the right side is rising. How do I write the fancy notation for this? As I move to the right on the x-axis, the y values are rising. You see how the arrow is pointing up? When you move up, you're talking about positive infinity. When you move to the right, that's also positive infinity. Okay? If that's confusing, think back to your regular coordinate plane, right? Negative infinity is on the left. On the x-axis, positive infinity is on the right. On the x-axis, on the y-axis, positive infinity is up from the origin, negative infinity is lower. Now, in a cubic, because it's an odd function, the left side and the right side have to do opposite things. So when I talk about the left end behavior, I want to make sure that I specifically say that as I go to the left on the x-axis, the y values do the opposite of what they did on the right end. So this time, oops, I'm going to color coordinate here. This time they're going down because the arrow is pointing down. They're going towards negative infinity. So as I move to the left, which is negative infinity, the arrow is pointing down, so your function is the y values are going down towards negative infinity. Okay, the highest exponent for this next function is to the fourth power. The leading coefficient is negative. Remember, the leading coefficient affects the left side. Now, quartics are w's. So you can draw your w however you want. It doesn't have to be perfect. Okay. Now, notice the leading coefficient was negative, which means that the right side should be falling. So I'm going to go ahead and write about that first. So the right side is falling. Okay. But first, before I talk about the y values, I need to talk about the x's. So as I move to the right, remember right end behavior on the x-axis, that's positive infinity. Then talk about your y values going down towards negative infinity. Quartics are even degree functions. So that means that both the left end and the right end are doing the same thing. So if my y values were falling on the right, then they should also be falling on the left. The only thing that changes is the beginning part, because now you have to tell them that as you move to the left on the x-axis, the y values go down. So look at the arrow. Okay, the last one is linear. This line is falling. But also, it's an odd degree function because the highest exponent is 1. That's odd. That means the right side is doing the opposite of what the left side. You see how the arrows are pointing in opposite directions? All right, so let's describe the right end. Remember, your leading coefficient affects the right end. So the right end, because the leading coefficient is negative, that means the y values are going towards negative infinity. They're going down. Okay, as x approaches positive infinity, so that means that I'm moving to the right, the y values are approaching negative infinity because they're going down. The left end behavior is going to be the opposite. Instead of negative infinity for the y values, it's going to be positive infinity because it's an odd function, remember, and the arrows are pointing in opposite directions. But your notation has to say, as I travel to the left on the x-axis, the y values are rising. So as I move to the left side of my graph, as I go more and more to the left, my y values are increasing. They're going up. So both of these are the answer, guys, both of them. When they ask you to describe the end behavior, you have to talk about both the left and the right end. And as always, my loves, if you have any questions, feel free to send me a message on Remind. Enjoy your day. Thank you.